Alright, we're going to be reviewing quadrilaterals and other polygons. The sum of the measures of the exterior angles of any convex polygon is 360. Does not matter what type of convex polygon it is. Sum of the exterior angles, one at each vertex, of course, is 360. How many sides does a polygon have if each exterior angle measures 20 degrees? Well, the sum of them is 360. So divided by some number of sides, which we don't yet know, equals 20. And so we want to solve this for n. So multiply both sides by n. So on the left side, the n's divide out to 1. And so 1 times 360, 360. On the right side, 20 times n is 20n. To get rid of multiplying by 20, divide by 20. 20 will go into 36 one time. Multiply, you get 20, subtract, you get 16, bring down the 0. 20 will go into 160 8 times. 8 times 20, 160, so no remainder, so 18 sides. Find the sum of the measures of the interior angles of a convex nonagon. Nonagon has 9 sides. So the formula we use for sum of the interior angles is n minus 2 times 180. In this case, we're looking at 9 as the number of sides, so 9 minus 2. When we talked about these at the very beginning, we looked at the number of triangles we could draw just using one vertex, drawing in all the diagonals from one vertex, counting the number of triangles. It always ended up to be 2 less than the number of sides. So that's where that n minus 2 comes from. So multiply this, and we get 1,260. Of course, we're talking about degrees. Find the measure of an interior angle of a regular heptagon. So now we're looking at a single interior angle, and it is a regular heptagon. Heptagon has 7 sides. Hexagon has 6. Heptagon has 7. So the sum of the interior angles, n minus 2 times 180. If we're trying to find each individual interior angle for a regular polygon, then we're going to divide that by n. And so we'll plug 7 in. 7 minus 2 times 180, and it's all over 7. 7 minus 2 is 5. 5 times 180 is 900, and then 900 divided by 7. So we get approximately 128.6 degrees. Alright, here we've got 6 angles, which also means 6 sides for this convex polygon. So we can use the calculation S equals n minus 2, 6 minus 2 times 180. That gives us a way to find the sum of these angles. 6 minus 2 is 4, 4 times 180 is 720. So the sum of all these angles is 720. Now you may notice we have 2 4x's, and then we have 4 3x minus 20 angles. When we add up all those angles, we get 720. Now you can write it all out if you want. You could write 3x minus 20 plus 3x minus 20 plus 3x minus 20 plus 3x minus 20 plus 4x, or you can use multiplication to write that a little bit shorter way. So we get 8x here, distributing our 4, we'll get 12x minus 80. We can combine those like terms. We get 20x minus 80 equals 720. Then we'll add 80 to each side. So we have 20x equal to 800, and then divide by 20. And so x is 40. So we found the value of x. That's the first part of what we want to do. We also want to find the value of, or the measure of angle A. Measure of angle A is equal to 3x, so 3 times 40 minus 20. So that's 120 minus 20, or 100 degrees, for the measure of angle A. So we did what they asked us to do. Alright, we've got a trapezoid. I know that because we have these two parallel sides. No other sides are parallel. So it is a trapezoid, quadrilateral with one pair of parallel sides. When we have a segment that is the same distance from each of the bases, we call that a mid-segment. It's the middle segment for the trapezoid. That mid-segment is equal to the average of the bases. So we'll have 8x minus 7, that base, plus 10x minus 1, and it's all divided by 2 because there's two bases. So it's the average of the bases. Trying to solve this, on the right side we can combine those like terms. 8x plus 10x is 18x. Negative 7 minus 1, negative 8. Since each of these happen to divide by 2, that would be a little bit quicker than multiplying both sides by 2. So we'll have 9x, that's 18x divided by 2, minus 8 divided by 2 is minus 4. We've got variables on both sides. If you want to get your variables together, you can subtract 7x. You have 2 equals 2x minus 4. And then to get rid of minus 4, add 4. That gives us 6 equal to 2x. And then to get rid of multiplying by 2, we'll divide by 2. And so we get x equal to 3. So x is 3. Our goal here is to find fj. So if we plug that in, fj is equal to 7 times 3 plus 2. So 21 plus 2, 23. Now this should be the average of the two bases. So we can plug in that x value and see. And I'll just do it real quick. Replacing this x with 3, we get 8 times 3, 24, minus 7, 17. And then if we replace this x with 3, 10 times 3 is 30, minus 1 is 29. So this mid-segment should be the same distance from each of these, from 17 and 29. And sure enough, it's 6 away from each of those. So like to go from 17 to 23, you'd add 6. To go from 23 to 29, you'd add 6. So it is the average of the bases. Alright, notice this is a kite. We know that because it has a pair of adjacent angles, or adjacent sides here that are congruent, and a pair of adjacent sides here that are congruent. So it is a kite. For a kite, the intersection of the diagonals is always a right angle. So we got 90 degrees there. This triangle and this triangle will be congruent, so the corresponding parts will be congruent, and so this angle up here will end up being 62 degrees. And so we've got a right triangle where we have two of the three angles. 62 plus 90 gives us 152. If we subtract that from 180, we'll get 28 for the measure of angle 2. The opposite angles in a parallelogram are congruent, so y must be 44. And then the adjacent, or the consecutive angles will be supplementary. So 180 minus 44, we get 136. Opposite sides are congruent for a parallelogram, so we can write 2x minus 8 equals x plus 16. Subtract x from each side. So we get x minus 8 equals 16. To get rid of minus 8, we'll add 8, and so we get x equal to 24. Alright, same type of thing happens for the y's. These other opposite sides are congruent, so we have 2y equal to y plus 19. Subtract y from each side, and so we get y equal to 19. We found the value for x and y. It should have said x and y up here. Number 10. So RK is 6, YZ is 10. What is PY? Well, for a rhombus, the diagonals bisect each other and they are also perpendicular. So we've got a right triangle here where we know 2 of the 3 sides, so we can use the Pythagorean theorem. The hypotenuse squared equals the sum of the legs, the sum of the squares of the legs. So we'll have 100 equal to x squared plus 36 when we square those. Subtract 36 from each side, we get 64. And to get rid of squared, we'll square root. Only a positive answer makes sense for a segment length. Alright, so ky is 8. And we're looking for py. Well, these will be congruent. And so if one of them is 8, the other is 8. So py is 8 plus 8, 16. Number 11, we're told that it's a rectangle. And uz is 7. We're trying to find RT. Well, for a rectangle, the diagonals are congruent and they also bisect each other. So all of these are congruent. They're all 7. And so RT is 7 plus 7, 14. Number 12, trying to give the most precise classification for a quadrilateral. All right, we got 2 pairs of opposite sides parallel. Other than that, we don't have other information, and so the most specific, most precise we can be is we can call it a parallelogram. Not only do we have it as a parallelogram, opposite sides parallel, but we also have that all of the sides are congruent, and so that makes it a rhombus. And then if all sides are congruent and we have all right angles, then that is a square. For a parallelogram, the diagonals bisect each other, and so C must be 2.5, A must be 3.2, and then the opposite sides in a parallelogram are congruent as well, so B must be 4. We want to form a parallelogram. The sides are parallel and they are also congruent. And so let's count from B to C. Let's count. We go down 2, we go to the right 1, 2, 3, 4, 5. So if we do that same type of movement down 2, to the right, 1, 2, 3, 4, 5. We should see where the fourth point is. We can make sure that these distances are congruent. So let's count from B to A. 1, 2, 3, 4, 5. So this distance is 5. So this distance must be 5 as well. 1, 2, 3, 4, 5. That is correct. We can go ahead and draw that in there. If you want to focus on just the parallelogram, we can erase that movement in red. And so D must be at 2, -4 to make that a parallelogram. Opposite sides are both parallel and congruent. All right, we want to state everything that we know about this. Well, if it's a rhombus, it's also a parallelogram and a quadrilateral. We can, since it's a parallelogram, we know that opposite sides are parallel. So we could say AB, that segment is parallel to DC. We can state that AD is parallel to BC. We can state that all of these sides are congruent. We can say AB is congruent to BC, which is congruent to DC, which is congruent to AD. We can say that the diagonals bisect each other. We could write that in words, or we can state that AF is congruent to FC. We could state that, and by the same reasoning, we can state that DF, that segment, is congruent to segment FB. There's lots of different angles that we could say are congruent. So we can say opposite angles in a parallelogram are congruent. So angle DAB is congruent to angle DCB. We can state that angle ADC is congruent to angle ABC. Those opposite angles in a parallelogram are congruent. We could also go for all of these other angles, like this angle is congruent to this one congruent to this one, alternate. All of these alternate interior angles are congruent. So this one with 4 marks will be congruent to this one as well. So lots of different things we can state there. And then of course we got vertical angles in here as well. So these are congruent and so on. But I don't have enough room to put 5 marks and 6 marks. But so you've got lots of different things that you can state there. Alright, so hopefully this video has helped you prepare for the quadrilaterals and other polygons test.